Hey there, today we're embarking on a fascinating journey into how our immune system and brain talk to each other, sometimes like old friends, other times like awkward strangers at a party. Grab your curiosity hat because things are about to get lively. Let's start with our immune system, the body's own superhero squad. You've got leukocytes, those are white blood cells like monocytes, neutrophils, and macrophages, zipping around fighting off bacteria and viruses. Think of them as the body's internal security team. Some of these cells hang out in the spleen or the thymus, which is like the training academy for immune cells. Now, when our body detects trouble, say a bacterial invasion, it releases signaling molecules called cytokines. These are like the emergency broadcast system. Cytokines include interleukins, tumor necrosis factor alpha, and interferons like interferon alpha. They coordinate the immune response, calling in reinforcements and ramping up inflammation. Think of cytokines as the body's version of a team chat, making sure everyone's on the same page. Sometimes these cytokines do their job a bit too well, causing what's called a pro-inflammatory response. Think of it as the immune system throwing a big fiery party. This inflammation isn't just confined to the body, it can reach the brain, crossing the blood-brain barrier, our brain security gate, especially during peripheral inflammations or when your body's battling infections. But what happens when this immune chatter impacts the brain? Well, microglia come into play. These are the brain's resident immune cells, acting like the neighborhood watch. When activated by cytokines or signals from peripheral inflammation, microglia can change shape and behavior, a process called microglia activation. While normally they keep the brain healthy, overactivation can lead to neuronal changes affecting neuronal morphology and functioning. And here's where it gets interesting. Activated microglia release more pro-inflammatory mediators, like prostaglandin E2, which can influence neural circuits, especially in areas like the medial prefrontal cortex, the brain region involved in decision-making and emotional regulation. Imagine microglia as tiny conductors, sometimes leading or disrupt neural activity, sometimes causing a bit of chaos. Now, stress is a big player in this story. Acute stress triggers the hypothalamic pituitary adrenal axis, resulting in the release of glucocorticoids, or body stress hormones. While these are helpful in small doses, chronic stress can lead to elevated glucocorticoids, which may suppress some immune functions but also cause neural alterations. For example, chronic stress and elevated glucocorticoids have been linked to depressive symptoms, anxiety, and even cognitive dysfunction like foggy thinking or memory issues. Speaking of depression and anxiety, these mood states aren't just psychological, they're connected to immune activity too. Elevated cytokine levels, especially interleukin 1 beta and interleukin 6, have been observed in depression. It's almost as if the immune system's overzealous response can influence brain circuits tied to mood. And let's not forget the role of cellular immunity versus humoral immunity. The cellular side involves immune cells directly attacking pathogens, while humoral involves antibody floating around. So next time you're stressed or feeling down, remember your immune system might be doing a little bit too much and your brain is listening too.